This is just a couple more quick examples on finding some derivatives with a little bit harder functions. To begin with, we've got 2 over x minus 5. So to find the derivative, we do f of x plus h minus f of x all over h, limit as h approaches 0. So just notice, of course, that we plugged x plus h in place of x. So this is f of x plus h. This is f of x. With a fraction, the first thing I needed to do was get a common denominator. So I multiplied this by x minus 5 over x minus 5. I multiplied this by x plus h minus 5 over x plus h minus 5. If you're wondering where the parentheses went around the x plus h, notice that they really weren't that important because it's just x plus h minus 5. So I've rewritten it down here with the common denominator. Okay, let me just right above here work the problem with getting rid of the parentheses. This becomes 2x minus 10 minus 2x minus 2h plus 10. Okay, so the 2x's are gone, the 10's are gone, and I'm left with negative 2h. Now remember, we also, let me just move this up. We also like to, in fractions, instead of being divided by h, we like to multiply by 1 over h. That gets rid of that. So what we have now is negative 2h over x plus h minus 5 multiplied by x minus 5 multiplied by 1 over h. We're doing the limit as h approaches 0. So the h's are gone. So I have negative 2 on the top. X plus, now once you get that cancellation, remember we plug in 0 again for h, so we have x minus 5 times x minus 5, which is just x minus 5 squared. This is our derivative, negative 2 over x minus 5 squared. Now it says find the slope at the point given. They've given us 5. Well, you plug in 5 here and you can't do it. You get negative 2 over 0. The slope does not exist there. Okay, I'm just going to make a little note. Slope does not exist. And you kind of say, well, geez, how did that happen? Well, look back at the original function. If I plug 5 in, that doesn't work in the original function either. There's an asymptote here. So remember our rules of differentiability, that if you either have a corner, a cusp, a vertical tangent, or a discontinuity, you can't find the derivative. Well, we'd have a infinite discontinuity at 5. So that's why, even though we could find the derivative for the function, it's not going to work at that point. Okay, in this example, we're looking at the square root function. So again, I've done f of x plus h minus f of x all over h, limit as h approaches 0. Okay, so again, you're just putting x plus h in place of x. To deal with the square root, we're almost always going to multiply by the conjugate. Remember, the conjugate has the same two terms, but the sign is different between them. And the reason that this is going to work is because when I multiply this out, the first square root of 3 times x plus h minus 1 times the square root of 3 times x plus h minus 1 is just 3 times x plus h minus 1. Well, then I multiply the first and last terms together, and that's pretty ugly until you see that I multiply these two together and I get the same thing but opposite. So they cancel out. Then I multiply the last square root. That gets rid of that, so it's just minus 3x minus 1. The bottom, of course, I've made uglier. I'm not actually going to multiply it out. I'm just going to leave it just as it was. We're still doing the limit as h approaches 0. So let me just get rid of the parentheses, kind of work it right above again. We get 3x plus 3h minus 1 minus 3x plus 1. Well, the 3x's are gone, the 1's are gone. I'm left with 3h on the top. and h times the square root 3 times x plus h minus 1 plus the square root of 3x minus 1. Okay. And again, we're taking the limit as h approaches 0. Well, the h's now cancel. Once that happens, we try and plug in 0. So you'll notice that we have a 3 on the top, and we have a square root of 3x minus 1 plus a square root of 3x minus 1 for 2 square roots of 3x minus 1. That's our derivative. So the slope at 4, well, we plug 4 in, so 3 or 2 times the square root of 11. So the slope at 4 is 3, 2 square roots of 11. Finally, the derivative of sine. Well, I've given you a graph of sine here, and let's just think about doing the graph. So we look, first of all, for where the derivative is 0. We're looking for spots where there would be a horizontal tangent line. Okay, so these spots right here where the slope is 0. I'm going to mark those on my graph. Of course, that's where the derivative will be equal to 0. Then I go between them. The function is increasing, so it has a positive slope, so the derivative must be positive. Over here, slope is negative, so the derivative must be negative. Over here, slope is positive, so the derivative is positive. Over here, it's negative. Hopefully that looks familiar. The derivative is cosine. So if you plug 1 into cosine, or I'm sorry, 0. If you plug 0 into cosine, you get a slope of 1.